In this video, I'm planning on going over some examples of how to draw Lewis structures. A few rules or steps for drawing Lewis structures. And if you go through these steps, you're going to end up with the correct structure most of the time. So the first thing you want to do is, if you have a molecule, so let's use, I think this is easiest just seeing some examples. So let's say that we have NH3 and we want to draw what the structure looks like. So the first thing we would want to do is calculate the number of valence electrons. And you do that from the periodic table. So if we were to look at the periodic table, we could figure out that nitrogen has 5 valence electrons, so we have 5, and hydrogen has 1 valence electron, but then we have 3 hydrogens, so this is 1 times 3, so we have 5 plus 8, so NH3 has 8 valence electrons. So we've done the first step, we've figured out the number of valence electrons. The next thing we want to do is pick our central atom. So the rules for picking your central atom are usually, so you want your central atom to be the least electronegative atom in the molecule. But with that said, hydrogen can't ever be a central atom. So I'm going to say not hydrogen. I'm going to just add that to this rule. And so hydrogen is actually less electronegative than nitrogen, but we can't pick hydrogen for our central atom. So there's really only one choice in this molecule for our central atom, and that's nitrogen. So then what you want to do after you've picked your central atom is draw a skeleton structure. So you write down the atom that you picked for your center and put the other atoms around it. And then I usually just draw bonds to the central atom. And at this point, don't worry too much if your figure's exactly correct. You're going to, later on when you calculate formal charge, let's say that you've gone through these rules and you've come up with a few possible figures that would work. You can use this formal charge calculation to figure out which figure is right. So don't get too caught up on getting this exactly right at this point. Just get something drawn. So following these rules. Okay, so now what we want to do, so we've picked our central atom, we've drawn our skeleton structure. So what this subtract electrons means is each one of these bonds accounts for 2 electrons. And so we've accounted for, so what we want to do when we're drawing this figure is we want to account for all of the valence electrons. So we're going to show where are all of the valence electrons in this molecule. Are they bonded? Are they lone pair electrons? So that's what we're trying to figure out. And so each one of these bonds accounts for 2 electrons. So we have 1, 2, 3, 4, 5, 6. So by drawing these 3 bonds, we've accounted for 6 electrons. So we're going to subtract that from the 8. So we have 2 more electrons to account for. So the next step is to assign leftover electrons to the terminal atoms. And what we're doing is we want this to be, I'm going to put, so they have octet. So what we want to do is assign electrons to the central, or to the atoms until the atoms have an octet. And an octet means that they have 8 electrons. So we want to give all of these atoms 8 electrons. Well, except for hydrogen. Hydrogen can only have 2 electrons. So never put lone pair electrons on hydrogen. So hydrogen can only have 2 electrons. So these hydrogens already have, like if we look at this bond accounts for 2 electrons. So each of these hydrogens already have 2 electrons. So we can't assign any more electrons to the terminal atoms in this specific molecule. So now we go to the next step. Assign leftover electrons to the central atom. We still have 2 more electrons that we need to assign. So we're going to go ahead and put those on the nitrogen. Now what we want to do is say, okay, does the central atom have an octet? Well, if we look at nitrogen, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So the nitrogen has 8 electrons, so we can say that this is done. Although, let's say that we had gone through this and we had a couple possible structures. Let's look at how we would determine if that structure is good by calculating the formal charge. So what the formal charge is it's the number of electrons in the free atom. So for instance, with nitrogen has 5, the free atom of nitrogen has 5 electrons, and the free atom of hydrogen has 1 electron. So it's the number of free electrons minus the number of bonds minus the number of lone pair electrons. Oops. So minus the number of lone pairs. So let's calculate the formal charge on nitrogen. So we have nitrogen, and we just write down what these different values are. So the number of free electrons in nitrogen is 5, minus the number of bonds. We have 1, 2, 3 bonds, minus the number of lone pairs. We have 2 lone pairs, so we subtract 2. That's equal to 0. And then let's do hydrogen. Okay, so we have hydrogen has 1 free, so a free hydrogen atom has 1 electron. So we put 1 here, minus the number of bonds. It has 1 bond. So we're just looking at one of these hydrogens. So 1 bond, minus the number of lone pairs. It has 0 lone pairs. So this is equal to 0. So looking at the formal charges, the first rule for formal charges is that you want the formal charge to be as low as possible, preferably 0 on each atom. So we have a 0 formal charge on the nitrogen and on the hydrogens. So this is most likely the correct structure. So I'm going to erase some stuff and then do another one. Let's do N2. So we have N2, and we want to draw the Lewis structure for this, and then we want to do the formal charge calculation. So the first thing we want to do is figure out the number of valence electrons. And at this point, I don't recommend starting to draw anything yet. Just go down the steps in order so you don't get confused. So to figure out the number of valence electrons, we know that nitrogen has 5 valence electrons, and we have 2 of them, so we have 10 valence electrons in N2. And so now what we want to do is pick our central atom and then draw the skeleton structure. We have 2 nitrogens. One of them is going to be the central atom, one of them will be a terminal atom. When we're drawing this figure, it doesn't really matter which one we pick because they're both the same. So let's just draw both nitrogens and a bond between them. I'm going to say this one's the central atom and this is the terminal atom. Okay, so we've accounted for 2 electrons with this bond. So we subtract 2 from our total. So now we have 8 valence electrons left to place. And now what we want to do is assign leftover electrons to the terminal atoms so that they have an octet. So we have 1 terminal atom, so we're going to it already has 2 electrons. We want to give it 8, so we're going to give it 6 more. So 1, 2, 3, 4, 5, 6. Now we've assigned 6 more electrons, so now we subtract the 6 and we have 2 more valence electrons to assign. Now we go to this rule, assign leftover electrons to the central atom. We have 2 more, so we're going to go ahead and put those on this nitrogen, which is our central atom. Now we subtract these 2 electrons, and we have 0 electrons left. We've placed all of the electrons that we have. So now let's go to this question. Do we have an octet on the central atom? This is our central atom. We have 1, 2, 3, 4 electrons. 8 electrons is an octet, so if we only have 4 electrons, we don't have an octet. So then we need to go to this rule. So we have no. So do you have an octet? No. You need to create multiple bonds. So the way we do this is we can't, when we create these multiple bonds, what we're doing is moving around electrons. So we have these 6 electrons that we placed on this terminal nitrogen, and what we want to do is say, okay, well, instead of having all of these lone pairs on this nitrogen, some of them are going to be multiple bonds. So what I'm going to do is just move 2. So I'm going to take these 2 electrons right here, and I'm going to move them over here and create what's referred to as a double bond. So if I do that, I'm going to have nitrogen with a double bond, and I'm still going to have the 2 electrons on this one. And now I have 4 electrons or 2 lone pairs on this one because I moved 2 off to create the double bond. Okay, now let's go to our question again. Does the central atom have an octet? Well, let's look. This is our central atom, so we have 1, 2, 3, 4, 5, 6. We have 6 electrons. We need 8 for an octet, so we don't have an octet yet. So what we need to do is we go to here, so we have no, we don't have an octet, so we create multiple bonds. So what we're going to do is so we can't put more electrons on this atom or on this molecule. Like, we've already put all of the electrons that this molecule has are already here. All we can do is rearrange what we have. So what we're going to do is take 2 more electrons off of this nitrogen and move them over to create another bond. And this will create what's referred to as a triple bond. So now we have nitrogen with a triple bond, and this nitrogen still has the 2 lone pairs. And I'm just going to draw them here. So this is the same thing. These 2 lone pairs, I had them here before, now I've just moved them here. And then I moved 2 electrons off of this nitrogen to create this bond, and I still have the 2 electrons on this one. So I draw these 2 lone pairs. Okay, do I have an octet on the central atom? Let's count these up. So I have 1, 2, 3, 4, 5, 6, 7, 8. Yes, there's an octet. So then we can say, okay, well, it's usually done at this point. But we want to go a step further and calculate the formal charge of this nitrogen. Both of these nitrogens are going to have the same formal charge because they each have 3 bonds and they each have 2 lone pair electrons. So we have 5. So if we look at a free atom of nitrogen, we have 5 electrons. So we have 5, and I'm calculating the formal charge for nitrogen right now. So I have 5 valence electrons in the free atom, minus 3 bonds, minus 2 lone pairs. So this means that there's a 0 formal charge on both of these nitrogens. So this is the correct structure. Now I'm going to erase this and do another example. Okay, let's do this one. First thing we want to do before we start drawing anything is figure out how many valence electrons we have. So one oxygen has 6 valence electrons. So I'm going to put 6, and then we have 3 oxygens. So 6 times 3. So we have 18 valence electrons in this molecule. So now what we want to do is pick our central atom. Since we have 3 oxygens, we just pick one. So they're all the same, so it doesn't really matter which one we pick. So I'm just going to draw 3 oxygens. And so this is the central oxygen, and these 2 will be the terminal oxygens. And I'm just going to draw 2 bonds between them. So if we go back, so we have our central atom, we have our skeleton structure. Now we need to subtract the electrons that we accounted for with these bonds. So we have 2 bonds. Each bond accounts for 2 electrons. So that means we have minus 4 electrons. So we have 14 valence electrons left. So now what we want to do, so we go to the next step, assign leftover electrons to the terminal atom so that they have an octet. So these are our 2 terminal atoms. We already have 2 electrons from this bond. So we want to put 6 more to give an octet. So we have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So looking at these terminal atoms, each one has an octet. So we have 1, 2 from the bond, 3, 4, 5, 6, 7, 8. So each of these terminal atoms has 8 electrons. We've placed 12 electrons because we put 6 on each atom. So minus 12, we have 2 valence electrons left to place. So now the next rule, assign leftover electrons to the central atom. So we have 2 left, so we're just going to go ahead and put those on the central oxygen. Subtract those, so now we have 0 valence electrons. Okay, now let's go to this rule, or step. Is there an octet on the central atom? Well, let's look. We have 1, 2, 3, 4, 5, 6. We only have 6 electrons on the central oxygen, so we don't have an octet. So we need to create multiple bonds to get the octet. So what we're going to do is move 2 electrons off of one of these oxygens and create a double bond. So if we redraw this, now we have a structure that looks like this. And now let's figure out if we have an octet on the central atom. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we do have an octet. So let's go ahead and do our formal charge calculation. And so let's start with this oxygen here. So with this oxygen, we have, first of all, the number of valence electrons on a free oxygen is 6. So we have 6, and I'm doing this one right here first. So I have 6 minus 1 bond minus 6 electrons. So this is, or 6 lone pair electrons. So this is equal to minus 1. 6 minus 1 minus 6 is negative 1. So this oxygen has a negative 1 formal charge. Now let's do this one. So this one we have 6 electrons in the free, or 6 valence electrons in the free atom, minus 3 bonds, minus 2 lone pairs. So that's equal to plus 1. So this one is a plus 1, this one's minus 1, and this oxygen we have 6 valence electrons in a free oxygen, minus the number of bonds is 2, minus 4 valence electrons. So this one's equal to 0. So we have a 0 here. So it turns out that this is the correct structure. We have a minus 1 and a plus 1, but this is the lowest formal charge that we can get. So one question with this though is, so I'm going to redraw this structure up here. So I have this structure. What's preventing this from forming this structure? So these two structures are different, but they each represent this molecule. So these two structures are both valid representations of this. So it turns out that when you have multiple structures where you can represent this molecule, in this case we can represent this molecule with these two structures. These are called resonance structures. And so you can either draw these like this, or sometimes people will draw these like this. So the oxygens, and then I'm just going to draw a dotted line to represent that this isn't a full double bond, but it's also not a single bond. So this is how to represent these two representations of this structure, and this is called a resonance structure. So you erase this and do one more example. Let's do this one. So CO3 2-. So this is an ion, it has a charge on it. And so what we want to do is, when we calculate our number of valence electrons, we need to add 2 more electrons, because this structure has 2 more electrons than what the valence electrons are, and that's why it has a 2- charge. So what we're going to do is find our valence electrons. We have carbon. Carbon has 4 valence electrons, and we have an oxygen which has 6 valence electrons, but we have 3 oxygens, so that's times 3. And then we have plus 2, we have 2 more electrons, because this has a 2- charge. So we just add those electrons to our total number of electrons that we account for in the structure. So if we add all these up, this is 24 valence electrons. Now what we want to do is pick our central atom. So we do that by picking the least electronegative atom. Carbon is less electronegative than oxygen, so carbon is going to be our central atom, and I'm just going to draw the oxygens around the carbon and put in the bonds. So that accounts for, so we've drawn the skeleton structure. Now we want to subtract the electrons we've accounted for with these bonds. Each bond accounts for 2 electrons, so I have 1, 2, 3, 4, 5, 6. So I have -6 valence electrons. So I have 18 valence electrons left to place. And so I go to this next step. Assign leftover electrons to the terminal atoms until they have an octet. So these oxygens already have 2 electrons, because they have 2 electrons from each bond. So I'm going to give each of them 6 more, so they each have 8. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've placed 18 electrons, so -18, and I have 0 electrons left to place. Now this next rule, assign leftover electrons to the central atom. We don't have any more electrons, so we don't have any more electrons to place. Going to the next rule, is there an octet on carbon? Well, let's look. So we have 1, 2, 3, 4, 5, 6. Carbon doesn't have an octet, so we need to create multiple bonds. So what we're going to do is move 2 electrons off of one of these oxygens and form a double bond with carbon to give carbon 2 more electrons. So to save room, I'm just going to draw the double bond and erase 2 of the electrons. Okay, so now what I want to do is figure out the formal charge on each of these atoms. And we should end up with a net formal charge of -2 because we have a -2 charge on this ion. So let's start with this oxygen. So there's 6 valence electrons in a free oxygen. So we have 6 minus, the number of bonds is 1, minus, and then we have 6 lone pairs. So this is -1, so we have a -1 here. And then on this oxygen, we have, so there's 6 free electrons, or sorry, there's 6 valence electrons in the free oxygen atom. So we have 6 minus, the number of bonds is 2, minus 4 lone pairs. So this is equal to 0. So we have a 0 formal charge on this one. And then this also has a -1 because it's the same. The formal charge on this oxygen is the same as this oxygen because they have the same number of bonds and lone pairs. And then for carbon, we have so we have 4 valence electrons on a free carbon atom. So this is 4 minus, we have 4 bonds minus, and then 0 lone pairs. So this is equal to 0. So we have a -1 charge here, -1 here, 0 here, and 0 here. So if we add all those up, we have a net -2 formal charge, which is what we're expecting for this molecule because it has a -2 charge here. So now let's erase this real quick. If we look at this, you'll notice that this can actually have 3 different structures. So we could have carbon, so we could have the one that we drew, which is this. Or we could have the double bond here, so then we could have this structure. Or we could have the double bond here, so we could have this structure. So all of these structures are equivalent to each other. So this could be redrawn, and so this is what's referred to as resonance structures. So these are resonance structures. And this can be represented with the following structure. So we just draw, in place of this double bond, we just draw a dotted line. So this is the resonance structure for this molecule. So the best way to draw these is to go through the steps in an ordered manner. If you go through each step one at a time and don't try to skip steps, even though some of this, it seems like it would be really easy to just do it in your head. If you go through these steps and don't try and skip them, you're gonna almost always end up with the correct structure. Usually mistakes happen when you're trying to skip steps or do steps in your head and then you make a mistake somewhere. So go through this, when you draw these, go through the steps one at a time, write everything down, write down your number of valence electrons, write down where you have the electrons to start with and then where you're moving them so you can see where you're moving electrons around. And the best way to get good at drawing these structures is to practice drawing them. So I hope this video was helpful. Thanks for watching.